First of all, thanks everyone attending. Thank you, Max, for presenting. I'm going to introduce you real quick. Max is the CEO and co-founder of Preset. He has worked at the leading edge of data and analytics his entire career, helping shape the discipline and influential roles at data-dependent companies like Yahoo, Facebook, Airbnb, and Lyft. A leader in the open source community, Max is the original creator of Apache Airflow and Apache Superset. So with that, Max, I'm going to let you take it away, and I'll keep an eye on the chat from there.
Awesome. Well, thank you so much. And all right, so it looks like we're a fairly small group here this morning or today, depending on where you're at in the world. So there are about, I think, 14, 15 people on the call. So people are still joining. So welcoming everyone. And I would love if people want to raise their hands and make it more conversational, since we're such a small group, I would like to welcome that. I'll try to keep an eye on the attendee list, and I believe if people raise their hand, I will see it so we can kind of weave in questions and make the Q&A as we go. Otherwise, I'll just get started. So today I'm talking about analytics trends and data engineering. So it's really looking at big trends, some that are more recent, some that are deep trends that are just accelerating in modern data teams. And as a data engineer practitioner, so I've been a data engineer most of my career, and I'm really interested in understanding how these trends are affecting data engineers too. So I'll kick it off and get started. I've got a quick intro slide on me, but I already got introed. So if there is a common trend thread to my career, is the fact that I've been building data tools. So for about like 20 years, since the very early days of my career, about like 20 years ago, I started building all sorts of data products, data tools, been doing a lot of data engineering. So just working with data for the bulk of 2 decades. And then more recently, so in about 2014 is when I started working more directly on open source. So that's when I started Apache Airflow while at Airbnb. So Apache Airflow is a data orchestrator. Or it's an orchestrator like mostly used for data pipelines. And soon after, I started Apache Superset, which is a data exploration and visualization platform, very much a modern BI tool. And more recently, a few years back, I started a company called Preset that's around Apache Superset. And we essentially bring Apache Superset to market as a service. So for people who are not familiar with Apache Superset or have not tried it in a little while, I would urge you to go and try it. So Apache Superset is an open source platform. It has grown so much over the past like 6 months to a year. It's definitely like accelerating fast. So whatever you've experienced in terms of like Superset, it's probably good to take a new peek. And the absolute best way to do that is probably to go to preset.io, where you can get started very quickly. And you can use it and try it for up to 5 people for free. So that means it's a really easy way to get started and take a look and see if it works for you and your team. With that, I'm going to jump into the talk. So a little bit more context on the talk. So about 4 or 5 years ago, I wrote these 2 blog posts that are behind there that are called The Rise of the Data Engineer, The Downfall of the Data Engineer. So it was really trying to define the role and some of the challenges around the role, as it was still an emerging role. And now we are 4 or 5 years after that. And I thought it was a really good time to look at the trend in modern data teams and trying to understand how this affects organization as a whole, but also like the role, how is the role of the data engineer shaping up in light of these new trends. So today I'm gonna go very wide and shallow. So the idea is to talk about a dozen or so trend that I've identified. And there's this companion blog post for this talk that's called How the Modern Data Stack is Reshaping Data Engineering, which is essentially the same content as I'm gonna explore today. Today is more conversational, hopefully, and it's much more, I would say, just looking and brushing through the trends, and then the blog post goes a little bit deeper. I'm hoping to do a series of blog posts on the topic too, where I'm going to dig deeper in the areas that need a lot more that have a lot more depth to explore. So that's just introducing the blog post. It is up today. It got live. It got published yesterday. All right. So first trend I'm going to talk about is open source being everywhere. So that's not a new trend, right? Like that's probably started with Hadoop or even before that. But it's a trend that is accelerating. So a few things to say about that is that it's really clear that if software is eating the world, right, like open source is eating up software. And clearly a large part of the modern data stack and the stack that people are choosing and using today is open source, right? The bulk of the tooling is open source tooling. One thing that's interesting too is that increasingly software is becoming open source from the inside. It's kind of getting eaten up from the inside. And by that, I mean that if you look at software that you run today, even proprietary software, it's increasingly made out of larger percentage of open source libraries and components. What's new with this trend? So I think this trend is accelerating quite a bit, largely, I would say, due to venture capital getting invested in commercial open source companies. So with people proving the model up front, the pioneers at places like Databricks and Confluent pioneering the model of commercial open source companies. I think we've seen venture capitalists seeing that as a huge opportunity and then helping boot up a lot of commercial open source companies. So I think we're going to see a lot more of this as a lot of capital is getting invested. Remember that, I think the venture capitalists, I think they pick the winners. They also make the winners because like money certainly helps on that journey. So open source, super relevant, will increasingly be relevant over time. Next trend I want to talk about is data infrastructure as a service. So about 4 or 5 years ago, when I wrote the original blog post, I believe I was at Airbnb or transitioning to Lyft at the time, and we had large data infrastructure teams at both these companies, and it was required if you wanted to be a data-driven company. Back then, you had to invest in very rare skills of the data infrastructure folks, and I think that's much less true today with the rise of really good tooling that as a software as a service type offering. So we have the rise of SaaS in the data space. We have the pay-as-you-go model. So if you're a very small company, you could kind of just get started with first-class tools and grow along with these tools. We've also seen the legitimacy of SaaS and data expanding. So that means like maybe 5 years ago, a lot of people were shy around the idea of using cloud services and multi-tenant type services for their data. I think over time now with compliance effort and just like kind of culture shift in terms of like letting people move their data to the cloud, I think that's much more enabled than it used to be in the past. Next topic here is data integration services. So a huge part of what data teams had to worry about and what data engineers had to do in the past was to get data inside the warehouse and out of the warehouse into different SaaS offerings. So companies use dozens, if not hundreds, of SaaS services as they come into existence, and it used to be like a huge chunk of work to get all that data into the data warehouse. So we've seen services like Fivetran, Segment, Meltano, Airbyte commoditizing and just making it like super easy to get your data in your warehouse, usually in its atomic form. And those are just like no-brainer services that people can use today or should use today. Similarly, or more recently, we've seen the rise of reverse ETL tooling with things like hightouch, Grouperoo. Sure, there's other actors in the space, but generally the idea here is to take all that product-centric data and all data coming from anywhere in the warehouse and back into your CRM system or really any other SaaS tool that can benefit from having your referential data or behavioral data or really any kind of data that might exist in your warehouse. Next trend here, I'm going to try to go fairly fast because I'm trying to go through about a dozen or so. This one is ELT kind of taking over or getting significance over ETL. So I think in the past, there's been like special purpose ETL tools, and I won't get too much in the jargon here. I'm assuming that the people in the audience like mostly understand, what ETL and ELT is. If not, encourage you to go see the blog post where you can find some references and links to more of that information. But point being here is that organization have made large investments in their data warehouse to serve, ad hoc queries and serve like just analytical workload in general. And what we've seen is people increasingly do their data transformation within the data warehouse. It makes tons of sense for a variety of reasons. Main one being that you do have this like highly performant, distributed, high investment in this data warehouse, and might as well just do the transformation there. So more and more we see the pattern of like stage your data, transform it in the warehouse. And we've seen less and less special purpose ETL tools being used in favor of a more SQL centric approach, which is the next trend. Maybe before moving on to that, I think there's something interesting in the fact that Spark itself as like one of the most popular compute engine for ETL and data transformation as also developed into a database recently with Spark SQL, right? So people increasingly use Spark as an analytics database as well. So it shows like not only that we use the data warehouse for transformation, but the transform engine is also becoming a data warehouse and kind of blurring these lines. Next trend, I think it's a pretty old one. There's nothing super surprising on that, but there's some interesting things to talk about. The first thing is like, I don't know who in the audience here has ever had nightmares about mountains of SQL. So for me, I spent the bulk of a decade writing much more SQL than I should have, and that was like 2000 to 2010. And then there's definitely like, been suffering from like, operational creep of all that SQL to manage and maintain. And clearly, I think what we've seen over the past few years is that SQL is here to stay, right? So it's not a new trend. It's been there forever and probably will be there forever. Many of us thought that we're going to move to like more expressive data API, like kind of data frame APIs, things like Spark and Apache Beam. The reality is we're seeing that a lot of people are very much doubling down on templated SQL. I see it personally talking to a lot of people who use Airflow. They use a large chunk of what Airflow is used for is templated SQL. And we also, I've seen the rise of DBT and the analyst engineer, which I'm going to talk about next. But here, I think essentially what we know is like we're probably signing ourselves up for another decade heavy in SQL and templated SQL. Luckily, the tooling around templated SQL is getting better. But clearly SQL is here to stay, and it's very likely that your children and grandchildren might also have nightmares about mountains of templated SQL. Quick things like, I don't want to be too rough with SQL. I think there's a lot of really good reason for this trend. I think SQL is like this super deep standard, right? That is well known by people. That's easy to learn. The mental model for it just works for people. And I want to say that I'm not above it too. Like when we decided to roll out solutions at Preset, we decided to go with templated SQL just because it's convenient and it's so easy and everyone knows it. So clearly there's some really good things about this. And the main thing being that it enables the rise of the analytics engineer, which is the next trend I'm going to talk about here. So first, I want to say it's been really cool to see analysts learn Git and SQL over the past 5 years or so, right? And even decade ago when I joined Facebook, there was definitely analysts. People were primarily analysts that were already writing tons of SQL and scheduling pipelines. So I think it's been a trend, and now we see it more and more becoming a reality. So people who have the analytics kind of data analyst mindset and skills who are also now able to to write SQL and put things in source control, which is great, right? In the past, we had all this dark matter SQL running God knows where, and now that has moved to much more structure and into source control, which is a really good thing. I think one thing that's interesting to think about there is that it's offering this new pivot point between people who are primarily vertically aligned, people who are primarily horizontally aligned in data teams. So by that, what I mean is vertically aligned, meaning like people who their primary allegiance is to a product team, right? People who work as part of a different subject area. So if you're at Airbnb, you might be part of the risk or the fraud detection team, right? Or you might be part of the bookings team or the host team. So people whose primarily allegiance is a certain vertical, can be the analyst engineer, and that pushes the data engineer a little bit more in the horizontal functions of the team, where they get closer to things like infrastructure and performance optimization and things like making sure that that things are done the right way in a performant kind of way. So definitely a trend here that's going to keep moving in that direction. Especially as we see more of the democratization of the analytics process. So this other trend I'm talking about, there was this previous trend that was more around the idea of like democratizing access to data, and that's been like very well adopted and implemented places where people recognize everyone in my organization needs access to data to do their work. Let's make sure that they can answer their own question and self-serve and get access to the data they need to power their daily processes. But now beyond that, I think what we're seeing now is the whole analytics process becoming more democratized. So what I call the analytics process here is the process by which data is logged or instrumented, ingested, enriched, transformed, analyzed, and consumed. And what we're seeing is like more and more people are enabled through better tooling, better frameworks, through data literacy being on the rise, right, to partake in this process that's really important for an organization. So primarily engineers and PMs, but I think we're still very much in the information age, and in this age, we'll see just more people becoming more sophisticated with data. Next topic is the one I was just talking about, really, which is the data literacy and data and specializations around data roles also being on the rise. So very much the idea here is that data is key and a differentiator or a competitive element for companies, and companies are investing in data. And what happens with this is it creates more people knowing more about data, and then as a byproduct of this, we see specialization around data roles. Much like, maybe there's some parallels here to be drawn with software engineering, where you'll see like people specialize in like backend, front end, DevOps, and all like SecOps, and there's compliance engineers now, right? Like so I think we see more and more areas getting called out and existing as sub verticals of in the data landscape. And I think something that's interesting too is that people don't have to be pigeonholed into different portions of this, right? People can decide to be more breadth oriented or to have like certain specialty, but secondary skill sets as well. That's pretty interesting to think about. Another thing that's interesting to think about is that maybe data specialization and data is more accessible to the information worker in general than software engineering. So for a while, we're talking about how everyone was going to learn to code in the next decade, right? Everyone will be a software engineer and everyone will learn to code because this is just the direction that we're going. I think we realize that coding is not for everyone, and then not everyone's going to be a software engineer. I think the on-ramp for data literacy is smoother and is more. I think it's more accessible to more people. and it's more, I think the payback is faster. So I think we're going to see that accelerating and maybe getting, moving faster in that direction than on the software engineering side of things. And apologies for the barking here. It's still it's still COVID. Let's see here. Before I'm also moving on to the next trend is the emergence of data ops and data observability, which is really like one of the specific areas of specialization that is really emerging out as a clear role and specialty in data teams. So here, very related to the previous trend, what we're seeing here is essentially people that are becoming much more focused on operation observability. Data engineers as analytics or analyst engineers are pushing up towards their vertical, and data engineers more on the horizontal type side of the pivot are becoming are pushed more towards data operations and data observability. So here, not only we see specialization in roles, but we see also like new tooling supporting the people whose functions are closer to this. I'm not sure if it's a super interesting place to be though, right? Like, so you almost take like the less exciting part of data engineering maybe, and pushing people in that direction. But like anything else, right, with the right tooling, the right approach, and the right best practices, I think that can be a really fast moving and interesting place to be as people like care more and more about metadata, about data quality, about data timeliness, and just reliability in general. As this becomes really critical to organization, this role is going to become increasingly valued, and then the tooling is becoming better, making it a better place to be over time. Next topic is the erosion of the semantic layer. So not everyone here may be familiar with the semantic layer. So let me describe it very quickly. And this is a deep area where I'm going to be writing deeper blog posts about in the coming weeks or months. So there's definitely a lot going on here. But for people not familiar with the semantic layer, it is an abstraction that historically has been existing inside business intelligence tool. And it is a business abstraction derived from the technical implementation layer. And it's a model layer that uniformly maintains business logic hierarchies, and calculation. So making it kind of bridging between your physical database models and the people who want to ask questions and self-serve, right? Like the semantic layer helps with metadata for more people to do this. We've seen this layer for a variety of reasons migrating over time into the transform layer for a variety of reasons. One is the fact that this layer living in proprietary BI tools is a problem, especially as people use multiple business intelligence tools. They have to maintain multiple instances of that semantic layer in different places. There's also the fact that with the transform layer now becoming more democratized, there's an opportunity to go and add a lot of that logic in a place where logic is well managed and well maintained and accessible to all tools. So I think we're seeing some of that migrating to places like dbt, Airflow, Spark, right? Wherever computation is done, wherever you create your models is probably where you want to add and manage and maintain a lot of the semantics that are related to these models. So a trend, I think that will continue evolving. That's like very pivotal. I think right now we don't know exactly how and where and at what speed it's going to go, but I think it's getting defined like right about in this time in history. Next trend I'm going to talk about here is like the data governance decentralization. So for me, I think this is like a deep old trend. When I joined Facebook in 2012. Things look much more like they do on the right here in this slide than they looked on the left. We already had like thousands of people working with data every day at that time. And the data warehouse was a big, I'm not sure if I'm going to say mesh or mess, but it was kind of a big, happy mesh, messy mesh of things with all sorts of people owning different data sets and and this like very complex web of dependencies
Say,
across.
Max,
Yes.
I hate to interrupt you, but we had a really good question here from Mr. Gonzalo. He's asking that, on top of SQL, version control, data visualization, and probably Python, what are the other top 3 technical skills that a good analytics engineer should have?
That's a good one. Let's see. So I think the core of an analyst engineer, to me, I would say like what's really important is to have the analytical mindset and the domain knowledge, right? So it's like to really understand what's important to your product team and really understand your product. Here, I'm assuming we work probably at a product-led organization, but in any case, like whatever organization you work as part of, you need to really understand and question the depth of the product that you work on first. So this is more like the analytics kind of mindset. Next, I would say being very proficient in SQL and data modeling, data structure. Well, so SQL first to query the data. And now what's new with the data analyst, the analyst engineer role is that analyst engineers are also scheduling pipelines, right? They're creating pipelines. So I would say then core would be SQL, data modeling, data orientation, being able to find where the information you're looking for resides and how to extract it. And then I think increasingly, I would say if there's a job description for an analytics engineer, they're going to assume you have something like DBT and Airflow, a little bit of Python, maybe, and then just knowing your way around Git or Git GUI to be able to check your things, in and out, source control. Hopefully that answers the question, and then I'll keep going and I'll make sure to save some time to get some questions at the end and to make myself available over the next half hour or two for people to ask questions. But yeah, so decentralization of governance is going to keep going, right? And that's one of these things that becomes increasingly important as your organization grows. If you have you're part of a small startup, you can probably have a centralized data team that that takes care of everything data. But as your organization grows, it becomes more important. There's a lot of interesting parallels here to be drawn with the microservice architecture world. I'm not necessarily arguing that, we should, microservice architecture is perfect and we should apply all the learnings there and just like shove it into the data side of the equation. But I think there's some learnings there. The main one being, I think, is with the microservice architecture world, we use software architectural concept to save organizational problems in organization, right? We had this issue of like who owns what and who's in charge of what and what's the contract between teams and people and services. And I think like we need probably similar construct and contracts in the data world, in the data governance world. It's more challenging for the fact that data, I think, has more gravitational forces around it. And that it's harder to segment and cut data apart. All right, so I've got a few more things to go through and we're almost at time. So I'm gonna rush through the 2 last trends that I have. So next one is computation framework. So when I started Apache Airflow in 2014, something that was behind in my mind at the time is that this would be a low-level DSL that would be able to grow, on which people could grow higher-level abstractions. Just a second here. I think I've got the house cleaning crew getting in the house. I'll be right back. Okay, I'm gonna lock this in here. All right, apologies for that. Good thing that my time is coming to an end, but yeah, so the general idea is like we're gonna see these higher level abstraction, I call it parametric pipelines or computation framework. So these high level constructs on top of computation, on top of these like data transformation primitives that we all know and love that are expressed in SQL. I think we need these higher level constructs that are higher level abstractions to create these reusable components on top of things. We see that with the metrics layer. We see that with feature engineering frameworks, becoming more prevalent, and A/B testing frameworks and other type of construct. The last trend that I'm talking about here is that every product is becoming a data product. with the rise of data literacy, with I think we're seeing essentially every SaaS platform, every important product having some analytics component to it. And we're going to see a lot more interactive data visualization transcend all products and all tools that we use every day so that we can see the data and really understand what's going on in these different products. And with that, that leads to my conclusion. So a few things, there's a few caveats here. First one being that everything is in high flux, right? So, so things will keep moving really quickly, and things are not about to settle and are going to keep moving. And I also wanted to say that my point of view is somewhat subjective as someone who lives in the middle of Silicon Valley and, talking to a specific segment of the data world. And last thought is welcoming people to check out our blog on Preset.io, so preset.io.blog/blog. So if you're interested to follow on these kinds of topics, I'm going to be blogging about them over the next months and years. So that's it. Maybe the last thought before I go open up to Q&A is the future has not been built. I think data and data engineering is behind like software and software engineering. So that means we've got some catching up to do. We're going to do a lot of that catching up very quickly, but there's a gap to fill. I think that's exciting. It creates all sorts of opportunities for all of us practitioners and builders in the space. So excited for what is to come. And with that, that's it. Thank you so much, everyone.
All right. Well, first, thank you. Thank you very much for that. Secondly, Mr. Lyons had a question. Is data mesh, as far as you can tell, a repackaging of the idea of governance centralization for a specific audience, for example, management?
Yeah, well, so I looked at some point, I heard there was like a lot of people talk about data mesh. So I tried to read as much as I could around it to really understand what this movement is about. I thought they did a really good job at I think it came from like more of a consulting firm than direct practitioners. And they did a really good job at summarizing some of the challenges and the things that are difficult for organization in this day and age around data and data governance, and the centralization, decentralization play seems like a really key important issue to larger and fast growing organizations. I think they did a really good job at summarizing that. For me, I think they put a new kind of layer of semantics of like, hey, we're going to call data set data products now. We're going to assume that no one was kind of treating data like data products and push in that direction. And I think it comes short in terms of like defining new data modeling techniques or like, it's like, how do you implement it is still very unclear to me, right? Outside of like renaming some things and calling certain things different names, it wasn't clear to me exactly where I would start to implement this. So I think I'm curious to see, where that goes and how people go and move these ideas forward in the future.
All right. Anyone else with some questions? Oh, first of all, Dave liked that answer. So secondly, Mr. Gonzalo had another one. Which tools for building and scheduling pipelines are the most relevant nowadays? For example, for scheduling, deploying dbt pipelines.
Well, so there's a panoply of tools, and there's different like use cases and personas. I think one thing that we see in the modern data stack is that there's not a single tool or there's not a single platform that's going to eat the whole thing, right? So depending on who you are and what your role is and what you're trying to achieve, you have a different set of tools that you probably want to use. I would say, I think dbt is great in the sense that if you do want to manage tons of SQL and schedule it, it does that very well. But often you also need to schedule, things like, Python scripts and machine learning type of more specific processing and maybe some notebooks, as well as, bigger like Spark jobs and things like that. So often you need a bigger orchestration engine that can go across data warehouses and across tooling. And I think Airflow is everywhere from what I see still. And Airflow is like really focused on orchestrating all of this. We've seen the rise too of like the tools that are more on the data flow front. So that are workflow engines that are maybe a little bit more focused on data flow. So things like Dagster, and Prefect are seem to be emerging in some ways. But what I hear too is that people who use dbt heavily often use something like Airflow to go and schedule their different dbt projects and fit that in a world where there's also like all sorts of heterogeneous workloads.
Okay. We have 3 more questions. So if you've got time, then they're ready for them, and we can run this as long as we need to. So, all right. So let me start with some of their actually the QA section. So as a data owner, how do you avoid critical dependencies breaking as you avoid your data, as you evolve your data model? Would you use an entity service model where people can access data via layer, or downstream consumers connect directly to the database?
So the easiest way to not break anything is probably to not change anything, which is absolutely like a bad advice here. So we want to enable data engineers and people crafting data sets to move fast and move forward, right? And I think what we've seen with operational creep is that people get really afraid to change anything because they don't understand well what's downstream and the web of dependencies. So there's good tooling to do dependency analysis, right? Like really understand your DAG and all of the data assets downstream of the things that you're changing. So things like Amundsen, Data Hub, I like all these data catalogs that are lineage aware. There's a Datakin and Open Lineage, to help understand this web of lineage. I think the tooling still has to grow in terms of like making it easier for people to do change management. So when I talk about the downfall of the data engineer, so that's a blog post I wrote a few years back. Change management and operational creep were like, some of the huge issues that existed at a time. They still very much exist today and are a challenge for all of us. In terms of like data modeling, like what I generally preach, or tell people is to try to avoid, deleting things and then just kind of doing like more additive and changes. So creating new columns instead of, changing the definition of some or deleting columns, and then, deprecating columns as you go, and kind of treating data sets in a similar way.
Okay. And 2 quick notes here. One, for those who are needing to go or attend something else, this will still be recording, so we can catch this later. So if you ask a question, we don't get to it, we're not going to leave it go. But let me jump back over the chat here. Mr. Vidal asks, where is preset superset fitting in the headless business intelligence trend? How do you foresee the evolution of this trend?
Yeah, so there's a bunch of different trends here. I think headless is interesting. One thing I'm much more interested in and focused on is the idea of like, how do we enable every product to become a data product, right? So I talked about this trend of essentially like every SaaS platform, every product, every mobile app is going to need to, or is going to be interested in presenting an analytics layer as part of the application. So that means like we're going to see interactive data visualization and exploration and dashboarding transcend all the tools. So I think Superset is in a really good place to offer its building blocks for application and product engineers to go and add to build this analytics portion into their product, starting with an embedded BI, which is like a way to bring a dashboard or to bring pieces of BI inside existing application, but then also like through an SDK where you can bring interactive data visualization easily inside your application. I think embedded, more specifically on headless BI. So part of the reason why BI is the ultimate no code, or is the first and probably most developed no code application of all, right? 20 years ago, we already had very sophisticated no code construct under BI, is because it's very complex and hard to express as code. So I think we're still going to see a lot of no code there, but what we're interested is to also provide, the full spectrum from no code to low code to full code, and enable people to kind of move on that platform wherever they see fit, and maybe evolve towards like heavier code over time.
Okay. And it looks like our last question, let's let someone else gets in, is Mr. Bono mentions that the reverse ETL looks interesting. Will managing SQL models in them be a problem as usage grows? And this is being compared to transformation and DBT.
Well, yeah, so it's like we've implemented some of that reverse ETL, at Preset. So here I'm talking more as a, less as the person talking about trends and more as a practitioner who's been involved in doing that. And I think what we did is, like, first we created a schema that has structures, data structures that are prepared for the purpose of reverse ETL. So, tables that are called, user to contacts in HubSpot, right? Or in our case, we're really looking to bring some product type analytics inside of HubSpot, which is our CRM. And I think we created some specific models to that, where we do specific change management. So if we change these, we know we need to change the reverse ETL. And then and then over time, we can just evolve that schema to bring all the things that we need to our CRM. And that's been working like any other data asset, I think, for us.
Okay. I think that's everybody. I think you mentioned you maybe hang around the lobby for a bit longer. So again, Max, that was great. That was a lot of information. We're going to keep this recording. So thanks to you. Thanks for people answering questions. Thanks for me for being so cute. And that'll be end of here, and we'll catch y'all pretty soon.